Welcome to this advanced masterclass on time series analysis. Today, we delve into one of the most powerful forecasting tools in a data scientist's arsenal, the SARIMA model. We will specifically focus on how to capture and predict those massive recurring peaks we see in retail during Christmas and in tourism during the summer. To understand SARIMA, we must first understand the anatomy of a time series. Any complex data signal can be decomposed into four distinct components: the trend, which shows the long-term direction, the cycle, the residuals or white noise, and our guest of honor today, seasonality. Seasonality refers to periodic fluctuations that repeat within a calendar year. Think about Amazon sales. Every December, there's a massive spike due to holiday shopping. Or consider airline ticket prices for Mediterranean destinations, which skyrocket every July and August. Standard models like ARIMA fail here because they don't expect these repetitions. That is where the S for seasonal in SARIMA comes into play. Let's break down the acronym. ARIMA stands for Autoregressive Integrated Moving Average. When we add the S, we get seasonal ARIMA. Formally, it is expressed as SARIMA PDQ times PDQS. The lowercase letters represent the non-seasonal part, while the uppercase letters represent the seasonal patterns, with S being the period, for example, 12 for monthly data. The P, autoregressive component, means we use past values to predict the future. The D, integrated part, involves differencing the data to make it stationary, ensuring its mean and variance don't change over time. The Q, moving average, uses past forecast errors. In SARIMA, we apply these same concepts but at seasonal lags. Let's look at the Christmas spike. Retailers often see 30 to 40% of their annual revenue in Q4. If we use a simple ARIMA, the model treats the December peak as an anomaly and smooths it out. A SARIMA model, however, remembers what happened last December and projects that behavior forward, acknowledging that the anomaly is actually a predictable pattern. Now, consider the summer spike in the energy sector or tourism. In countries like Spain or Italy, electricity demand peaks in July due to air conditioning. In SARIMA modeling, we would set our seasonal period S equals 12. The seasonal differencing, D equals 1, would involve subtracting last July's value from this July's value to stabilize the seasonal trend. To find the perfect parameters, we use the ACF and PACF plots, autocorrelation and partial autocorrelation functions. For seasonal data, we look for significant spikes at multiples of the lag S. We also use the Akaike Information Criterion, or AIC, to compare models. A lower AIC suggests a model that fits well without overfitting. In conclusion, SARIMA is the gold standard for monthly or quarterly data where human behavior follows the calendar. Whether it's stocking inventory for a December rush or pricing hotel rooms for a summer getaway, mastering seasonal lags is the key to precision. References: 1. Box, GEP, and Jenkins, GM, 1970. Time Series Analysis, Forecasting and Control. 2. Hindman, RJ, and Athanopoulos, GA, 2018, Forecasting, Principles and Practice. 3. Gujarati, DN, 2021, Basic Economics.